Hi, everybody. Thanks for joining us. We'll give just a couple minutes here, let people get signed on, and then we will get started with the webinar demo. So just sit tight and we will get going here in just a couple minutes. Okay. Well, hello, everyone, and thank you for joining us today. I am Zach Scarano, the Director of Product and Software here at Noraxon. And today we'll be introducing the Noraxon Biofeedback App, a mobile-first solution designed to bring EMG biofeedback into everyday clinical workflows. And so before we jump into the demonstration, I want to just briefly frame why EMG biofeedback is such a valuable tool in clinical practice. So, EMG biofeedback gives clinicians something that's difficult to obtain through just observation alone. It allows us to directly visualize muscle activation and not just whether a patient can perform a movement, but shows how the neuromuscular system is coordinating that movement. And so this can reveal things like underactive muscles, compensatory activation patterns, timing differences, or even fatigue during repeated tasks. And because of that, EMG biofeedback has become an important tool in many areas of rehabilitation. So the next question is, where is this actually used in practice? So EMG biofeedback is used across a wide range of clinical scenarios. In orthopedic rehabilitation, it's often used after procedures like ACL reconstruction to help restore the quadriceps activation and overall neuromuscular control. It's also widely used for shoulder retraining, helping patients reduce compensatory activation and restore proper movement patterns. In neurological rehab, biofeedback can support motor relearning after stroke, where patients need to rebuild voluntary control of muscle activation. Another important area is pelvic floor therapy, where EMG sensors can help patients learn how to correctly activate and relax muscles that are otherwise difficult to perceive directly. And so across these scenarios, EMG biofeedback helps clinicians turn muscle activation into something that's visible, measurable, and of course, trainable. And so that leads us to the next point. So EMG biofeedback itself is not new. In fact, this has been a core application of Noraxon EMG systems for many years, since the inception of our company. But what the biofeedback app does is it brings those capabilities into a simplified mobile environment. And so clinicians can move from sensor setup to training to session review and reporting, all within a streamlined mobile application. And so this allows for EMG biofeedback to just fit much more naturally into everyday clinical workflows. And so with that context, let's take a look at how the biofeedback app actually works. And, before we jump into the demo, it's helpful to understand that the biofeedback app includes three different training modes. So each of these modes are designed for a specific purpose. And the first is just the standard biofeedback mode. So this allows users to monitor and train up to four muscles simultaneously. And this is mostly useful for targeted muscle up or down training or evaluating coordination patterns during movement tasks using that real-time data. The second is template training, and this uses two channels of EMG. So one muscle serves as the reference template, and the other, the training muscle, is set up to then be able to learn or replicate the activation pattern from that reference template. So this is particularly useful for symmetry retraining. And then the third is a work rest mode, which also uses two channels, but focuses on more of a structured activation and recovery interval type of a style. And so this makes it useful for fatigue and endurance protocols and much more structured training workflows where you're looking at activation and deactivation across an exercise repetition. And of course, you'll see examples of each of these modes in the demo once we get there. So in the next few minutes, we'll walk through the core workflows of the biofeedback app. We'll start with sensor setup and patient management, and then move into the real-time EMG biofeedback. From there, we'll demonstrate MVC normalization, threshold-based training, and the two specialized training modes. Again, we've got template training for symmetry retraining, and then the work rest protocols for looking at fatigue and endurance profiles. And then finally, we'll look at how the recordings can be reviewed and reported directly within the app. And so, with that overview in mind, let's go ahead and take a look at the biofeedback app in action.
Welcome to the Noraxon Biofeedback app demonstration. We're going to step through the app today and look at everything from sensor setup to the different recording modes, report options, and everything in between. After launching the app, we arrive at the dashboard. This allows us to manage our patients, access all of the measurement modes, and do our sensor setup. So first, we can click on or tap on connected sensors. Then that will give us a menu showing us the different sensors that are nearby within the range for the Bluetooth connection. Simple tap of connect allows us to connect to these sensors and have them available for us for measurement. Very seamless, easy to use, don't have to fumble or fuss with the different complex sensor connection options. Everything is handled inside of the app. Those connected, we can see we've got them connected down here in the dashboard, and this now sets us up to be able to create a patient. And so we can tap here, brings us to the patient window, click new, and then we can enter the patient's information. Very limited information is required, just first name and last name, and then everything else is at your leisure. With that information in there, we can save that patient, and then we can make them our active patient. This means that this is where all the recordings that we're going to make, they're going to be assigned to this patient, and we can obviously change that active patient as we need. Now that we've assigned the sensors or set the sensors up and got them connected to Bluetooth, we'll access our first measurement mode, which is biofeedback mode. This then shows us the muscle diagram, which we can use to assign these sensors to the muscles of our choosing. For this first activity, we're going to look at some upper body muscle activation, and so we'll assign these sensors to the lower trapezius muscles. I select that muscle on the diagram, and then I can pick which sensor is assigned to that muscle. We have the ability to move this muscle man around if need be, so we can get it out of the way, or zoom in on these smaller muscle groups if needed, if we need better access. But again, just tapping on that muscle and then tapping on the sensor assigns that sensor to that muscle group. Next, we'll get these sensors set up onto our subject here, and then we'll move into the real-time measurement. All right, we're going to place these sensors on the lower traps, and so I'll have Lindsay sort of pull back just to activate these muscles. Place that sensor down. The electrode going across the muscle fibers, and then we'll get the same one on the other side. So that should be good placement for us there. Now with our sensors set up on the subject, we can return to the app and we can continue to our live measurement. So we hit continue, the signals will start to stream. We'll see data coming through on the sensors. And in this case, we can see the bars going up and down here. Some options that we've got, of course, are to be able to change the views. And so if I click the settings wheel here, I can change the view type. Some other options I've got are to be able to change the smoothing, change the x-axis time sweep, or enable audio cueing for each of the different thresholds. Changing the view, I just hit apply, and now that shows us a different view of the signal. In this case, this is our line graph view. We have options to be able to adjust the scaling. So if we need to change the scaling so that we want to zoom out, we can do so individually for each of the different graphs, or we can do a global scale here as well. Other options include being able to adjust the threshold. So if we want to change that threshold in real time for very specific threshold training, we've got the ability to do that just by tapping on the orange line and moving it up and down to the desired level. And then next, what we can do is also set up an MVC normalization so that we can use this data for easy comparison between the muscle groups or from session to session. So we'll go ahead and enter that mode by clicking on MVC in the bottom right corner here. Turns green when that mode is enabled. And then what we have to do is just press the record button to record that calibration. What I'll have Lindsay do is just kind of extend and pull her shoulders back to try and elicit as much of a muscle response as she can. And we'll use that as the MVC calibration. What this takes is an average 1 second window, and it's looking for the highest average value over that 1 second window across that MVC recording, and it establishes that as the 100% value. So I'm going to count you in, and then you'll just go ahead and activate as much as you can, okay? All right. Ready? 3, 2, 1, go. So she's pulling back there. And hold, and that's good. When she's done, we'll hit stop. The MVC was recorded successfully, and now you can see that our data is represented as a percentage of that MVC value. The y-axis has changed as well, and the threshold values have changed also, and so we can set those targets to be a percentage of the MVC instead of just being a standard microvolt value. Okay, now I think we're ready to move into the recording of our exercise activity, where Lindsay will interact with the biofeedback data as she's performing the exercise. So now we're in our exercise area, and the first mode that we're going to be demonstrating is biofeedback mode. And so this is a mode that you would use to allow your patient or your subject to interact with this data in real time. Learning how to recruit certain muscles, look at the activation profiles between the different sides, as well as establish maybe some targeted threshold training. So we have options in here to be able to set those thresholds, to be able to normalize the EMG data to an MVC, and really allow for targeted use of the live EMG biofeedback data. Now we'll move into our exercise and show you how that all works. We're gonna have Lindsay do some face pulls to try to elicit as much of a muscle response from those lower trap muscles as she can. She can use the biofeedback to try and change the position as she's making or performing the exercise and see if she can change that activation profile. So as she starts, she pulls back. We can see the muscle activation pattern go up, crossing, our target threshold, which we have set at 50% right now. This is where changing the views can be helpful as well. And so we'll go to the bar graph view, which is a little bit easier to see. And you can see here, as it crosses those thresholds, it does change colors. So offering a little bit of a visual cue. We also have the ability to set up auditory cues too. So if we set those, enable those, then when the bar crosses the threshold line, plays a sound, gives an auditory cue to the subject that they've achieved that level that you're asking them to do. Other views include a circle view, which is another representation where this circle will contract or squeeze as the muscle activates. As the muscle relaxes, that circle gets bigger. So just an alternative view to be able to work with this muscle activation data. And then finally, we have our camera view, which gives us a digital mirror for the individual to be able to look at their form while also working with the biofeedback data. So next, what we'll do here is actually make a recording. So we'll go back to our bar graph view. Lindsay's going to complete a couple reps just trying to get across that 50% threshold, and then we'll take a look at the results. You ready?
Yep.
And go. So we'll have her do just 3 reps here just as a quick exercise, pulling back, trying to maintain that activation above the 50% threshold as she gets into that extended position. And then less releases, and you can see that muscle tension drops as well. So we'll stop there. Gives us a quick results preview, which shows us just some quick summary results of the session that we completed. We have the ability to change the name of the recording if we want to be a little bit more explicit with what that recording was capturing. We have the option to restart it if we want to, but otherwise we can hit save. And then that'll take us to the record viewer. In this case, it just gives us the ability to dive into the signals so we can see the activations that were happening. We have the ability to adjust the cursor to really pinpoint certain levels of activation. We can play around with the scaling here as well. But the next part of the workflow is just going to the report, which then produces some results for us, showing us how much time was above or below the threshold, mean and max of the activation profile throughout the recording, a nice symmetry measurement here, and then also the time series data plotted with the threshold line signified. At this point, we can add comments if we wish, or we can decide to send this report or even adjust the report and move some elements around or disable some elements if we wish. At this point, we would then take a step back and return back to our dashboard, and we'll move on to our next measurement mode. The next mode that we're going to demonstrate is template training mode. And so this is a mode that was designed to be used for symmetry restoration and helping with some neuromuscular re-education. So it allows you to set up one sensor on a template muscle to record the ideal or target muscle activation pattern, and then the other sensor on the training muscle. So this would be the muscle that might be recovering from injury, which then you would use the template to try and match that pattern, match the activation levels, and then of course we can see the reporting that's created from there. And so we'll enter template training. First setting that we have to decide is the duration of the template. In this case, I'm going to have Lindsay do some straight leg lifts, straight leg raises, And we'll have her do a couple reps, and so I'll choose 10 seconds for that template training. Hit continue. We then can assign our muscles to this, or the sensors to the muscles. We already have the sensors placed here on her rectus femoris muscles on both legs, and so we'll set those up. We're going to go with the right side as the template, and so that would be our sensor number 1, and the left side as the training muscle, and that is sensor number 2. These are indicated by the colors here, and they're also noted in the info panes for the muscle selection. When ready, we just hit continue, and then that's going to connect to start streaming data from our template sensor. We're getting data coming through. We can make sure that that signal's looking good. And then Lindsay's going to prepare to do these straight leg raises. I'll count her in and hit record. And that's where she'll record those reps to create that template for us. You ready?
Yep.
And 3, 2, 1, go. 1. So over the template window, they can try to complete as many repetitions as they want. When that's done, you'll see that there will be a new green button, which allows us to proceed to the training. And so when we click that, it then switches the connection to the training muscle or the training sensor. And you'll also see that the template is shown to us as like a shaded area in the graph for this muscle. So the goal would then be for the subject to try and match that activation pattern as best as they can. And so the data will start streaming in as soon as I press record. Ready?
Yep.
And 3, 2, 1, go. So this allows, again, for this ability to try and create a symmetrical activation pattern, or really train that muscle to be able to activate the same way that the healthy muscle has been activating. Once we've finished, we get a quick summary of results here. We can obviously restart that if we want to do a new recording, but otherwise we'll hit save. We then can view that activity and see how closely they were able to match the template, which Lindsay did a pretty good job there. And we can, of course, move to our report, which then gives us some information about the data, what the average and the max were as far as how they interacted with the templates, how much time was spent below, inside, or above the template, showing us the time series data, again, with the training activation data overlaid on top of that template. Now we can move on to our next mode. So our final mode that we'll be demonstrating is the work rest mode. And so this is a mode that was designed to set up more structured activation and endurance protocols. Allows users to set up the duration and number of repetitions to be able to track success metrics and the different activation options while interfacing with the app, seeing when to work, when to rest, and so just giving a little bit more structure to EMG biofeedback. So for the setup, we'll tap on work rest. Here's where we can define the work time and the rest time. And so we'll go ahead and maybe set that to 4 seconds for the work time. And we'll add a little bit more rest there, maybe 6 seconds, and we'll do 3 repetitions. When that's set, we then hit continue. We can then assign our sensors to the muscles. In this case, we are going to be doing some calf raises, and so we have our sensors set up on the medial gastroc. And so we'll tap that muscle. The left side I have as sensor 1. The right side I have as sensor 2. And then we can hit continue to move into the real-time data view. Again, I'll switch to our bar graph view just for a little bit more visual context here. And I'm going to adjust the scaling a little bit. You can set up MVCs for this as well. So again, just to allow a little bit more of a targeted threshold training. Those success metrics do interact with these threshold lines, and so performing the MVC allows you to define that threshold value that's been normalized to the max voluntary contraction. Gives you a little bit more of a control to be able to compare the activation between the two muscles. So we'll go ahead and do that really quickly. Tap MVC, and Lindsay's just going to do a contract and hold just to get that max contraction. In 3, 2, 1. And squeeze, squeeze, squeeze. And that's good. Hit stop. We now have normalized data, and we can set up those thresholds to be a little bit more of a accessible target for us. So we'll drop these down to about 30% or so. And then when we're ready to perform the activity, we can turn and face the tablet towards the subject, and we can prepare to do these exercises again with the idea or the goal to be able to eclipse that threshold line during the activity, during the work periods. So it's going to immediately start with a work period. Again, we've got that set up for 4 seconds, 6 seconds rest, and you'll repeat that sequence 3 times, okay?
Got it.
All right, in 3, 2, 1, contract and hold and relax. Contract and hold here in a second and go. So up at the top, you'll see those work rest bars going from left to right, the green indicating the work period and the blue indicating the rest period. Again, we have this set up for 3 reps. There's also a rep counter in the top left corner, so you can keep track of that as well. Once that's finished, then we get a quick results summary here. We can see our success ratio, basically indicating that we crossed that threshold during the work phase for more than 50% of that work phase. And then some quick metrics about the mean and the max values in the work and rest periods. Hit save. And then that brings us to the record view, which we can see those cycles, and we can see the time series data for all of those EMG activations during the work and the rest periods. So we can see during the green work periods that we've got some heightened EMG activation. And then in the blue rest periods, we drop down to those rest levels. And so a nice sequence of activation and deactivation of these muscles. If everything looks good, we'll hit report, and then that generates a PDF report for us to be able to use. We can distribute this to the subject or have it for our own records and send it out as needed. Again, providing the work success ratio and some information about the average and the max data during the work periods as well as the rest periods. That time series information, a symmetry calculation, and then we can add comments if need be. There you have it. Thanks for joining us for the demonstration of the Noraxon Biofeedback app. We're excited to deliver this new application to our customers to give them access to real-time EMG and some clinical workflows for using electromyography in practice.
Okay, so now that you've seen the Biofeedback app in action, I'd like to just briefly summarize a few key points. So the goal of this app is to make EMG biofeedback practical and easy to integrate into these everyday workflows. Clinicians can move from sensor setup to training to review and reporting, all within an easy to use mobile application. The app supports several different biofeedback approaches, as you saw, including real-time EMG monitoring, the template-based symmetry retraining, and then the structured work-rest protocols for fatigue and endurance training. And so together, these tools allow users to utilize EMG biofeedback not just for measurement, but also as a powerful training and rehabilitation tool. And so whether you're working on muscle activation deficits, neuromuscular control, fatigue and endurance, movement coordination, or symmetry restoration, the biofeedback app integrates directly into those interventions without adding workflow complexity. And so, with that all in mind, I'd like to briefly address a few questions that were submitted by registrants before the webinar. And so, a few good questions came in ahead of the webinar. And so, just touching on those briefly, one question was whether the application can analyze EMG signals directly or if additional processing was required. And so the signals in the biofeedback app are pre-processed automatically and displayed immediately, as you saw in the demo. This, of course, allows users to interpret the muscle activation during the session without any additional processing steps. Another question was whether the system can be used for retraining movement strategies, and the answer is yes, definitely. This is actually one of the primary use cases for EMG biofeedback. So with real-time EMG feedback, adjustable thresholds, the template training, all of those support neuromuscular retraining and improved movement coordination. So you can set that up to different muscles or different movement types and use that real-time data and the reporting as well to have an effect on that retraining. We also received a question about how many muscles can be trained simultaneously. And so in biofeedback mode, the app supports up to 4 EMG channels, so allowing users to monitor and train multiple muscles during a task. Template training and work rest modes use 2 channels for a more focused training. And finally, there was a question about exporting data. And so reports can be shared as PDF files using the standard mobile sharing options. And so this makes it very easy to send results or add them to clinical records. And recordings can also be exported as CSV files, which can be imported into the MR software if more advanced analysis workflows are needed. And so for those interested in exploring the biofeedback app further, there are several resources available. The app itself can be downloaded directly from the Apple App Store or Google Play Store. It directly connects with Noraxon EMG sensors, both the Core and Ultium sensors using Bluetooth. And for more detailed information about the app and its capabilities, I recommend visiting the Noraxon Biofeedback app product page on our website. And so this provides an overview of all the different features and will continue to be updated as new features are released. And we've also published a knowledge base article that walks through the workflows and functionality of the application in more detail. And so those resources provide a step-by-step explanation of the different training modes and reporting features that you saw demonstrated today, along with other key functions and options within the application. So with that, I'd like to open the session up for questions. If there's anything that you'd like to explore further, whether it's clinical applications, workflow integration, sensor configurations, or EMG biofeedback strategies, please feel free to submit your questions into the Q&A section. As they come in, we'll try to take a few minutes here to go through as many of them as we can. Let's see here. So one question that came in was about using licenses on several devices. And so the app itself is restricted, each license is restricted to a singular device. So if you need to have multiple devices with the application capabilities, then you'll need to purchase additional licenses. So again, one license per device. And those, of course, can be issued through your distribution networks. So thank you. Great question. Another question coming in about maintenance of electrodes and are they single patient use? Yeah, great question. So the electrodes that are used with our sensors are disposable. So they are single use. And so as you record a measurement and once you finish, then those electrodes should get thrown away and new electrodes should be used with every new session. And so as you if you try to reuse them, there's chances that the adhesive on the back of the electrode, won't be as resilient anymore. You'll not have a great connection between the electrode and the muscle. So yes, they're disposable and should be a new one should be used with every session. EMG validity studies. Yeah, there's several. We've been producing EMG technology for almost 40 years now. So we're pioneers of low noise electromyography devices, as well as telemetry devices and wireless devices as the technology has been advanced over the years. So our systems have been used in hundreds of research studies over that time, maybe even more, maybe on the order of 1,000 at this point. But yeah, I would just encourage you to go look on Google Scholar and search for Noraxon EMG. In terms of validity, it's typically not how EMG is referenced. Usually, you're using EMG to validate some other aspect, whether that's a movement coordination pattern. The electronics themselves are validated through like our certifications. So all of our devices are certified medical devices, and so they have to pass certain quality and safety standards in order to be registered as those devices. So happy to provide that information. It's available on our website as well. And then otherwise, definitely encourage you to just search for Noraxon systems in whatever research articles are most applicable to the application that you're looking to address. Yes, next question. Can the app be downloaded on older iPads? Great question. So there definitely is a limitation here. So right now, our lower limit is iOS 13, I believe. That is specifically noted on the product page. But our recommendation would be devices that were manufactured or produced in 2020 or later. These are going to have better processing engines. They're going to have, better performance and Bluetooth connectivity. So the key point is having the Bluetooth low energy connectivity. There are some older devices that have that, but that technology has been improved over time. And so again, for optimal performance and it would be devices that have been produced in 2020 or later, and then running iOS 13 and later. Let's see here. Great question. So this is coming in as kind of an aside here, but question is asking if we are developing any apps that would utilize our 3D motion capture sensors with mobile devices. And so, of course, something that is on our minds. Nothing that I can share at this point. But yeah, that's a clear use case is being able to utilize the inertial sensors to deliver information, whether it be about kinematic biofeedback or even some of the other routines that we have embedded inside of the MR software for doing different activity detection and so on. But yeah, thank you for your question. Let's see here. So, is it possible, for example, for audio biofeedback from the app related to the activation of specific muscles? Great question. So that is one of the features of the app is that you can enable audio cues which interact with the set thresholds, and these can be set up or enabled per channel. And so you can establish that threshold for, let's say, channel one. And if you have that audio enabled, when that muscle activation crosses that threshold, it goes above it, it'll play a tone. And then as it goes below that threshold, it'll play another tone of a different pitch. And so you have that audio cueing that can be utilized for that threshold training. And again, that can also be applied to up to the four channels that you have, each with their own tones as the muscle activation crosses the threshold line, going up or going down. Next question, are patient sessions stored for progress tracking over time? Yeah, so the sessions, if you record them, they'll be stored in the database. And so they're, of course, assigned to the patient that you have set up. And so you can manage that accordingly. As you saw in the demo, you can set that up to the patient name. And then as you record sessions, you'll develop that database. The database is backed up as well to cloud servers, and so you have a secure cloud server that can back that data up. But otherwise, it's also stored locally on the device as well. So both points of access there. Another question. So, is the code from MR4 the same for this app? I'm assuming you're asking about the licensing, and no, this is a completely separate software product with its own licensing. And so, if you're interested in purchasing this application, I would encourage you just to reach out to your local salesperson or distributor, and they can get you set up with pricing and a quote and get you that license. Let's see. Are there specific places to put the device on the muscles for optimal data retrieval? Great question. This is getting into more of how to use EMG. I would encourage you all to, if you do have these types of questions, please go on our website and look into our knowledge base. We have several resources that talk about how to use EMG and some of the basics around EMG. But just to quickly address this, yes, each of the surface muscles are going to have kind of a best practice placement. There are actual standards for some of the muscles, which have been produced by a governing body called CENIUM. These give very specific indications of where to put the electrodes. But otherwise, from a general perspective, typically what you're doing is you're placing the electrode where it's going across the muscle fibers, and then you position it on the active muscle on like the bulk of the muscle belly. And so, if you're palpating to find the muscle, you can obviously locate that. And then typically what we do from a practical standpoint is ask the subject to just try and engage or activate that muscle, see that muscle belly engage, and then wherever it's, in its most active state, wherever the center of that muscle belly is, that's usually the best place to put the electrodes. Let's see, is four channels currently the maximum number of channels, and is a receiver needed with the app? Great question. So yes, four is the maximum number of EMG channels for the biofeedback mode. And then our other two specialized training modes both only support two channels for more of a focused use case. And no, there's no receiver needed. The sensors connect directly to the mobile device through Bluetooth connection, so bypassing a receiver completely. Let's see. So a couple more here. So what differences does the app introduce in terms of artifacts obtained during EMG compared to standard Noraxon measurements? So as I noted, the EMG data is pre-processed. So from the Bluetooth stream, it's actually a 100 millisecond RMS window is applied to the EMG data. That effectively makes the sample rate for an EMG signal 100 hertz, and it's already smoothed and rectified. And so in terms of artifacts, typically that's going to be something that's related more towards your skin preparation and your sensor placement and how you have those sensors secure. The processing of the data and the streaming through Bluetooth really does not have any effect on that. Assuming that you're following recommendations and guidelines for proper skin prep, and you're attaching the sensors to the muscle bellies and making sure you have a good secure connection, then you should have really clean EMG data. And so our expectation, from a baseline perspective is, even with some minimal skin prep, you should be somewhere under like the 5 microvolt level. And then, with really diligent skin prep, you could probably even drop that a bit lower to under 2 microvolts as kind of a practical baseline. Second follow-up is, will the app be compatible with other devices in the same way as the standard Noraxon software? And, attached to that, there's been some questions about, is there an integration with IMUs? So, no, this app is specifically for EMG biofeedback at the moment. Of course, there's always opportunities or chances that we'll add in some additional components there to use for real-time biofeedback applications, whether that be the smart leads from the Ultium system or the inertial sensors. But at the moment, and as it stands today, this application is specific to the Noraxon EMG sensors only. So only providing that EMG biofeedback. And then again, so what's the best way to share the app with other therapists if you only have a single license? Again, it's the license is restricted to the device, and so you can give them your mobile device, or if you need to have the app on multiple devices, then multiple licenses will need to be purchased. So those are really the only two options for sharing the application with multiple people. Okay. Well, it looks like there may not be any others that have come in. So I just want to thank all of you for your time and all of the thoughtful questions. That was great to be able to address all those and such great questions. I really hope that this session gave you a clear picture of how the Noraxon Biofeedback app can support EMG biofeedback in these everyday workflows. Really appreciate your interest in using this technology and look forward to continuing the conversation. Definitely don't forget to follow us on our social media channels at Noraxon USA on all of your favorite platforms. And of course, do not hesitate to reach out if you have any other questions or you need information about the Biofeedback app or any of our other products that we sell. So thanks again, everybody. Really appreciate your time, and I hope you all have a wonderful day. Thank you.